Hello, I'm Jared Thompson, and I'm currently in IB Physics. I was interested in how the development of nuclear weapons changed the dynamics between nations, and how Japan was affected by the first and only uses of atomic bombs. I contributed to discovering what the impacts on humans were, as well as the historical references to nuclear bombs.
My name is Paul Freeborn, and this year I'm taking IB Sports Science. For this project, I was interested in how nuclear bombs work and how they differ from regular bombs. I was responsible for researching this, and I forgot what the last part was. Dang it! Presenting the mind map.
My name is Sophia Honerkamp, and I'm currently taking IB Biology. I was interested in doing a project on nuclear weapons because I'm really interested in global politics and how power is structured. And I also recently saw an episode of Last Week Tonight on nuclear weapons, which really piqued my interest. We all contributed to every part of the project, but I was responsible for the politics section of the video as well as the video editing.
The two main types of nuclear bombs are called uranium and plutonium fission bombs. Fission is when a neutron strikes the nucleus of either a uranium or plutonium isotope and splits it into multiple fragments, releasing a massive amount of energy. When the nucleus splits, it releases more neutrons that split other nuclei, causing an exponential chain reaction which causes an atomic explosion. Both uranium and plutonium bombs require the fission process to work, but they initiate the chain reaction in different ways. A uranium bomb uses a gun-type design and fires two amounts of uranium-235 at each other to start a chain reaction that will be strong enough to eventually set off the bomb. Little Boy, the bomb that was dropped on Hiroshima, was a uranium bomb. In a plutonium bomb, however, conventional explosives are placed around the plutonium-240 mass that will squeeze and increase the pressure and density of the plutonium. This increase in density ensures that when the first neutrons are fired, they are guaranteed to strike another nucleus. Fat Man, the bomb that was dropped on Nagasaki, was a plutonium bomb.
When looking back on history, there were only two instances where atomic bombs were used in warfare, and they both occurred within 3 days of each other. First, the Little Boy bomb was used on Hiroshima, covering a radius of 4.4 square miles. After Japan refused to surrender, the US dropped a second bomb, Fat Man, on Nagasaki. The death tolls are estimated at 150,000 dead in Hiroshima and 75,000 in Nagasaki. Interestingly, only half of these deaths occurred on the first day. Besides lethal wounds that may have delayed death for some, radiation was a major factor. After a radioactive explosion takes place, debris kicked up by the blast gets contaminated with radioactivity and becomes what is called radioactive fallout, which is when radioactive particles are spread outwards from the explosion, spreading the radiation even farther than the blast damage. Radiation occurs when unstable elements undergo spontaneous fission and release neutrons, colliding with other atoms and causing more and more fission. Sometimes, when the free neutron hits another atom, it causes gamma rays to be released. Gamma rays are very dangerous to humans because they will sometimes knock off an orbital electron of another atom, causing genetic mutation, or cancer, within the person. A study by Richard Turco of UCLA ran a simulation of a nuclear war in which 100 Hiroshima-sized bombs were exploded. It predicted that the resulting black smoke would spread around the world's atmosphere, blocking the sun's particles from reaching the earth. This would cause worldwide crops to fail and even potentially begin the largest ice age seen in all of human history. The best part? This is only 0.03% of the world's nuclear arsenal.
The development of nuclear weapons totally changed modern-day warfare. Winning a war was no longer determined by who has the most or better-equipped troops. Essentially, any country with nuclear weapons has the ability to inflict damage on another country regardless of that country's size. Contrary to what you might think, this didn't actually appreciably change the balance of power because of mutually assured destruction. This means that if a country uses nuclear weapons to attack another country with a nuclear program, then that country has second strike capability and they can send a nuclear weapon back. So the level of devastation potentially caused on both sides means that using a nuclear weapon is an absolute last resort. The consequence of this is that having a nuclear arsenal doesn't actually provide a country with very much political bargaining power. This issue is what drove the Cold War as both the US and the Soviet Union developed their nuclear arsenals, but no nuclear strike was ever actually carried out. There are relatively few countries now that have nuclear weapons. The countries in red are the only countries with currently active nuclear programs. Even between countries with nuclear weapons, there are countries with more power, which is really just the US and Russia. Between them, they possess 93% of the world's nuclear weapons stockpile. This means that they can theoretically bypass the limitations of mutually assured destruction because they have reached the state of nuclear primacy. Essentially, on their first strike, they have the ability to destroy all of the nuclear weapons that a country has, undermining their second strike capability. This has the effect on the world stage of providing the US and Russia with more political power, even over countries with their own nuclear arsenals. So, the development of nuclear weapons is in many ways responsible for the consolidation of power in our current system.
The first nuclear weapons used in battle were Little Boy and Fat Man, which were dropped on Hiroshima and Nagasaki, leading to the end of World War II. Nuclear technology continued to shape global relations. The Cold War was entirely shaped by mutually assured destruction, and the same ideas continue to shape global politics today, particularly as countries aim to achieve nuclear primacy.